All right, so this week we are going to start covering the ketones and the aldehydes, which are also a very important group in essential oils. Remembering now that we're on our oxygenated series. And so we're going to start with Roman numeral 3, which are the ketones. And are corresponding to group 3 there in your kit. The first thing to note, which you should already know, but we want to know what the defining functional group of a ketone is, and defined by some general carbon group bound to a carbon atom, which is double bound to an oxygen, and then some other carbon-based group. So this is called a carbonyl, C double bond O. And when we have this kind of situation, this is what we call a ketone. So this should be easy to spot in our skeletal structures, because everything else is just going to be lines and corners, and then all of a sudden you're going to see a double bond to an O, and it's going to stand out like a sore thumb when you're looking at these and trying to classify it. Some properties of ketones are, they are typically very strong and pungent. Not always, but many times they are considered more toxic to our biological systems. Not always, but a lot of times, and you'll see, we'll talk about examples of that. Their names, their formal names anyway, always end in O-N-E. Or they could end in the entire word ketone, but typically you will see the O-N-E ending, and it looks like one, but it's pronounced own. Always it's own for ketone. What would be this should be an easy one for a lot of you, what would be the simplest ketone? Obviously. Correct. Propanone, right, which is this. It's your simplest one, which is also known as what? Oh my gosh. Really? There you go, acetone. How many times have you used that in the lab? Yeah. Okay. And our most common ketone in all of essential oils is one that doesn't end in O-N-E, of course, to make things complicated. Anybody want to take a stab now? Anyone who has a little experience with essential oils in here, have a guess? You have their kit, so you can guess from it. It's camphor. Everybody's heard the name camphor, right? In fact, camphor is the root of a odor descriptor, which we call a camphoraceous note. Okay? And the structure of camphor looks like that. Okay? Camphor is also known as, and you can look this up, I'm not going to say it, but it's 1,7,7 trimethyl bicyclo brackets 2.2.1 heptane-2-one. Of course. So now you like camphor better, don't you? Now, camphor is found to in a major sense in things like rosemary. And when I say major, it doesn't necessarily mean it's the main component, but it could be. Usually in rosemary, maybe it might max out at, say, 30% or so. It's in camphor oil. There is an oil called camphor, which comes from a plant. Latin's name is Cinnamomum camphora. There's many varieties of it. Some are high in linalool, some are high in camphor, some are high in methyl eugenol, several other things. But camphor oil, rosemary is another one. Now, in camphor oil could be really high, but in rosemary oil, it's significant. Sage is another one. Spike lavender, which is a variety, it's a different species of lavender than the traditional lavender. Just some examples. And it is present in a lot of different things as a minor component. It's very, very common. Don't ask me why. Some of these things always amaze me just as an organic chemist, when you look at some of these structures, these crazy, wacky structures, and you think, why is that so common? It looks like it's not very stable, it wouldn't be hanging around, but it's not the case. Okay, so we don't have camphor, because that was a solid. I tried to minimize the number of solid. Oh, do we? Oh, good. That's right. The original version of this kit did not include camphor. So let's get that out then. Let's get the camphor out and just take a whiff of it. Does that odor seem familiar to you? Huh? No, there's a solid. You should have the crystalline material. This is pure camphor. Oh, you do?
Yeah, they have a liquid.
Okay. If you have the kit, you got pure stuff. If you have the sample, it's already, because that made it easier to, yeah. But the odor's the same, it's just going to be less strong. But it's a very strong component. Yeah. So this is what we call the camphoraceous note.
Yeah,
Now, compare that to your sample that you have that would have the camphor, and that would be your rosemary oil. Don't like the rosemary? Now imagine, have you ever cooked with rosemary? Have you ever eaten like rosemary herb on herb chicken, rosemary herb chicken, or anything like that? That should smell a lot like what it is. But you can definitely, hopefully, pick that camphoraceous note out of here, even though there's a lot of other stuff in here. I would not use minty to describe rosemary. Not minty. I would use herbal. I would use camphoraceous. It could even be terpenic, but I would not use minty. First and foremost, camphoraceous. What was the question? Okay. Somewhat terpenic, minorly so, but primarily camphoraceous, herbal would be good descriptors for that. The reason that camphoraceous is first is because herbal is more of a broader, and you'll see other examples of things that are herbal and not camphoraceous. Rosemary is a very important essential oil, a lot of production. And I think, I don't know, in our syllabus, is that one we cover in later in the oil section? Herb and spice oils? No, I didn't cover that one. But that's where it would fall under, would be an herb and spice oil. Major areas of production would be Morocco, Tunisia, Spain. But it's a very important oil for flavor. Pardon? You could call that a monoterpenone. I don't do that because there's so many ways that you could see when you go to a lot of people don't normally say that. They say monoterpenol because it's pretty obvious where that alcohol came from. In this situation, you know, to someone who's experienced, they can say, yeah, that came from a precursor that was a monoterpene. And that would be valid to say it's a monoterpenone or a monoterpene ketone, but generally it's not classified that way. Because there's more things that have to happen a lot of times to get to that ketone. So it could be losing some other things from that monoterpene starting material other than just what's necessary to get that ketone there. Okay, let's look at some other examples of some important ketones. But yeah, I mean, I could have technically subdivided this into monoterpenones and sesquiterpenones. But we'll talk about those in context, but I'm not going to expect you to narrow that down like that. I mean, if you want to say that, it would be fine. If I put camphor and you called it a monoterpenone, I would say fine. Or if you put vetivone, would be an example of a sesquiterpenone that came from vetiver oil. Vetivone, yeah. Okay, let's look at this one. Important one. Generally, you'll notice, and some of the times anyway, some similarities in naming. So this one's called Menthone, which is obviously the oxidized up form of menthol, right? And you can also have, there's some other isomers. You can have isomenthone and things like that, but this is the main one that you encounter. When you smell it, it's in your kit, you should, what's the odor descriptor that you would use for that, you think? Yeah, it's a minty. But notice the difference between it and menthol. And what are some things that, your first impressions?
It's kind of a little closer
You think this is closer to peppermint? A what? An acetone? Yeah. I can see what you're saying there, because that's kind of that feeling that a lot of the ketones give you, that it's a different, more like a more pungent odor, whereas the alcohol is crisper. I don't know. Even though they're both minty, they're different, minty in different ways, you know. But it also, it maybe not as harsh, but I guarantee you, if you sat there and smelled this for several minutes and just inhaled it, you're more likely to come away with a headache than smelling menthol. And that's just the nature of ketones. A lot of them are neurotoxins. I'm not saying I'm not saying this one is, but there are things like thujone, which is in cedar leaf oil, which is a neurotoxin, which is also in armoire, which is also known as, anybody know what armoire is? French word? Huh? It's also known as wormwood. Absinthe, yes. It's an absinthe. The thujone is an absinthe, and that's the toxic. Why absinthe is toxic is because of that thujone. But we actually have that oil. That I can get an example of that if you want to smell it. Absinthe. No, and that's why a lot of these, it actually smells nothing like licorice. In a lot of these drinks, these phony absinthe drinks that are out there aren't really not true absinthe. They're flavored with things like anethol, which is that licorice flavor, to make it taste better. But yeah, well, the real stuff is probably even more disgusting, and you'll see why when I'll bring that sample in. So obviously, the oil that we would compare that menthone to would be the peppermint oil, if you want to compare the component with a whole oil, and you might be able to pick out, that note.
How much of it's in there?
Typically, it probably maxes out at about 20 to 25%, somewhere in there. I would say 15 to 25%, depending on, peppermint has so many different origins, countries of origins. Even in the United States, you have differences between Midwest peppermint, which is grown here in Indiana. Midwest is Indiana, Michigan. Two main states. There might be some in Illinois and Ohio, but mainly Indiana and Michigan. And then you've got West peppermint, which is Oregon and Washington. Willamette peppermint, which comes from, those Willamette, and what's the other one? Yakima. You've heard of the Yakima Valley region out west, and Yakima's in Washington, and Willamette's in Willamette's in Washington. Yakima's in Oregon. Is there anything else that menthone is in? Yes. It's actually in your geranium oil. It can be in geranium, typically around 8 to 10%. Menthone, yeah. Menthone and isomenthone. Both are.
Menthol found in a lot of things.
No.
Menthol is also found in.
Well, really, the only thing that menthol's found in is pretty much peppermint and cornmeal. And it is in both of those things. But menthone is also found in other things where menthol is not found. And I can't think of really any other oil that has any significant amount of menthol other than peppermint and cornmeal. And have we talked about cornmeal at all? Have I mentioned that? Okay, that's important because it is a very big, majorly produced oil. Okay, peppermint is from the botanical Mentha piperita. And as I said, you have all these different varieties. You have Midwest peppermint, you have Willamette, you have Yakima, you have Indian peppermint, you have Chinese peppermint. Canadian. There's all kinds of different peppermint origins, but they're all of this genus and species. Now, there's another mint which is known as corn mint, which comes from Mentha arvensis. And by the way, when you're writing these Latin botanical names, the genus is always capitalized, the species is always a small case. And Mentha arvensis is a hardier plant. It's more disease resistant, produces higher yield of oil, and it has similar chemistry to peppermint, but it has naturally a much higher menthol content. Could be up to 80% in crude corn mint. So what they do typically is they will crystallize out the menthol crystals from the corn mint just by simply freezing it or cooling it. And that menthol will crystal out in those long needle-like crystals. And then the oil that's left, not all of it crystallizes out. The oil that's left is probably about 60% menthol, and that's sold as what's called dementholized corn mint oil. Okay? It's not dementholized, it has menthol, but it has less menthol than the crude corn mint would have. And that's where not anymore. It used to be, this is pretty much where all of your menthol production came from corn mint. You can't really crystallize it out of peppermint because the concentration's too low. It's only about 40 to 45%, and you don't really get it crystallizing out. It's much easier to crystallize out of this, and this is where your menthol production comes from to a large degree, because it was just cheaper to do it that way than to actually make it. But now there's been a big push for synthetic menthol on the market because a company which you may have heard of called BASF has developed, I guess, a really efficient way of producing menthol synthetically. Okay, specifically L-menthol. And this is, when I say menthol production, I'm talking about L-menthol, which is what the predominant isomer is in both peppermint and corn mint. It's almost exclusively L-menthol, even though and if we looked at, and we're going to talk more about menthol later because it's an important molecule.
When you crystallize it out of the corn mint, how much does that reduce it?
Like I said, when you get done crystallizing out the menthol, you're left with what's called dementholized corn mint oil. No, in the dementholized corn mint oil, which is the oil that's sold on the market, it's about 60% menthol still. There's not really any significant amount of crude corn mint that makes it to market because this is such a commodity. A lot of people buy the pure menthol for flavoring gum, toothpaste, whatever. Engineering your mint. This is huge production because a lot of peppermint from the flavor industry is re-engineered with crude mint plus whatever amount of menthol crystals they want to get their menthol level to where they want it for the customer's needs, so forth. So used to be, like I said, pretty much all natural menthol, but now there's a significant amount of synthetic menthol production that is on the market, which has alleviated some of the price pressure on menthol because it was becoming so used, so in demand. The price we saw go. I've seen menthol back in the 90s at probably $8 a kilo, and then it kind of did this and went up for a while, and then maybe $5 5 years ago, it was probably in the 30s. And then last year, it went up into the 50s and 60s. And now that some of this is really making it, this synthetic menthol is making its way into the market, the price is starting to come back down a little bit. But these markets are very lucrative if you know the market. I mean, you can play, I know guys that's one of their big items is menthol, and they'll just, buy low, sit on it, sell high because it's got a really good shelf life, it lasts a long time, easy to store, stable, and it's in such demand that it's literally like just a place to park money. When the price drops low, they'll park millions of dollars into menthol crystals, let it sit, wait till the market goes up and cash in. Then there's a lot of oils like that people do that with. These are commodities markets.
They're used for the R menthol.
Pardon?
They're used for the R menthol.
You mean the D-menthol? The D-menthol, I might have a sample. If I do, I'll bring it in. It's obviously it's the mirror image of the L-menthol. Almost no odor. Pretty amazing, really. So it's not the form that is active, obviously, in the body as much. It does, yeah, it does. But it's a very minor component in this in the plant. It's like 99% L. The people in the essential oil industry may not, but the people in the aromatherapy industry hate that stuff, because if it comes from man, it's not part of nature, because somehow man is not part of nature. I never quite understood that, but it can be different, and there are reasons. And we'll talk about. I'm not saying that the natural product doesn't have advantages over the synthetic, because it does. But what I'm saying is if you're just looking at pure menthol, and if it's pure L-menthol, the molecule is the molecule. It doesn't know where it came from. It doesn't know if it came from a peppermint plant or a manufacturing plant. It's still L-menthol. And it would act the same way in your body. But there is this mentality out there that if man makes it, the spirituality of it is dead, and it's not going to act the same way, it's going to be different. But now there is something to the natural form of the oil, and there's reasons why we really can't duplicate those in a synthetic sense, but there's nothing magical about it. Okay, anything else on that? So, okay, let's go on to the next important one, and the ketones. We kind of got off on a little diversion there, and that would be Carvone. Now, you asked about Carvone. You see now the difference in structure. Carvone is an important one because it is in spearmint. It's a major component of spearmint. So specifically L-Carvone. And it's in spearmint at anywhere from 60 to 80%. Countries of origin would be things like India, China, USA. USA is also big in spearmint. Both, again, Midwest, out west in Washington, Oregon. And then we have the D form, which is the main component in dill. And they're drastic, and it's also in dill, it's like 60%, 40 to 60, I would say. And it is the characteristic odor of dill. If you smelled D-Carvone, you would think of dill. If you smelled L-Carvone, you would think of spearmint. Mirror image molecules, drastically different odor. So let's take a look at that Carvone. And do we have a spearmint? Yeah, we have spearmint. Good. Yeah, so compare that Carvone. You smell that Carvone pure, you're going to think, yeah, it smells like spearmint. Then you smell the spearmint, and then you think, wow, that's a lot better. A lot more well, depending on your opinion, but I tend to like it better. So a lot more going on there. It's much cleaner, much simpler, the Carvone. What do you notice? Is there an odor that you can describe? Is there one of our descriptors that you could use to describe the spearmint oil over the straight Carvone? You think it's sweeter? Anything else? Not camphorous. You're getting closer. Yeah, herbal is, it is definitely a little more herbal, but you should feel that terpenic note, because it does have limonene and some other terpenes in there, and it give it that, which also gives it the herbalness. But right. So spearmint, obviously a very important oil for flavor use. We see it in gum, we see it in toothpaste, we see it in mouthwash, mints, whatever. You know, there's a lot of different things that it's in, so there's a lot of production of it. By the way, the peppermint spearmint candy, especially peppermint, you know, a lot of times you go to a restaurant, there's a history of why these things became candy, because it goes back to the origin of their uses in medicinal sense. Peppermint actually has a purpose to it, a function, in that it is a useful product for irritable bowel syndrome, peppermint oil. So, you know, after you get done eating a meal, you might have an upset stomach, feel a little nausea, whatever. You take some peppermint, and it would alleviate that nausea and that, you know, that stomach rumbling, whatever. And they just now incorporate it into a candy, but there was a therapeutic reason for that. Okay. The next one we're going to talk about is a simpler one. It's just a straight chain ketone. Known as Three-Octanone. Now, this one is not really present to a major degree. I mean, it's not like a main component of anything, but it's an important one, and I included it in the series because, you know, you have an example of some monoterpene ketones there, but I wanted to have a different type of ketone that's not terpene derived, or it's not, you know, the immediate result of some kind of simple reaction with a terpene, and that's Three-Octanone. It's in a few things, but it's a very important one in lavender oil. And a lot of people overlook its importance because lavender oil is mainly composed of linalool and linallyl acetate. We haven't had esters yet, but we'll talk about that. But this is probably in most good lavenders, this is in there at a little, maybe 1%, maybe a little over, right in that range. But smell how powerful that thing is. Pretty strong, huh? So you put that in 1%, I mean, in something like lavender, and it really gives that a lavender a nice feel. And it should be, in this lavender you have, this is a Bulgarian lavender. I have better examples. I wish they would have given the French lavender, it would have been more pronounced. But this is probably in here at maybe 0.75% in the Bulgarian. But if you smelled this versus a lavender that had, say, 0.1%, it would be a huge difference. Just that little bit of that little component makes a big difference. If you smell one that's 1%, you'd even notice a bigger difference. What does the Three-Octanone, does it remind you of anything? Soap, okay. Act mouthwash. I don't know that, so I can't comment on that. You know, you're getting close to something that someone said to me and it's always stuck. It's been 20 years ago. No, not that. To me, it reminds me of those, what they call those circus peanuts, those pink candy peanuts. You know what I'm talking about?
Yeah.
I wouldn't be surprised if this was used in the flavoring of those to some degree. I can't verify that. I mean, I could if I wanted to extract out the flavor and GC it, but so that's a good way of remembering it. You know, anytime you can associate these odors with something, you're going to remember them a lot better. And once you smell something, believe it or not, you never forget it.
Would that be terpenic, this one?
No, I wouldn't call it terpenic. I would call this pungent fruity.
Is there like a perfumer's list? Because I tried to find one online, like just to give us some words, key words to use.
There is a perfumer's wheel that has a range of descriptors that this lady, Mandy Aftel, sells. She's out in California, Aftelier. If you look up the perfumer's wheel on the internet, I'm sure you'll find it. They're not that expensive. It's just a laminated wheel with all the descriptors on it. So anyway, associate that. Learn, if you get these words keyed into your mind, and believe it or not, you'll never forget them. That's why you can remember. You may not remember names, but you'll remember a smell. I've smelled that before. And doing these exercises will help you get better at being able to recall those things. But if you can remember, I mean, if you think about an odor you experienced as a child, a very young child, and you never forget that. And that's because your odor and smell is closely linked to the limbic system in the brain. So once it's taken in and identified, and it's pretty much a part of you. It's part, you know, it's there. Okay, so any other oils that might have Three-Octanone, there may be some others, but lavender is the most important one to remember in connection with that. And remembering that it's not a major component, but it's such a strong component that it has a great effect. Okay, Anything before we move on to the aldehydes? Any questions over ketones? Key things to remember, being able to recognize, and this should be easy to recognize, when you're asked to identify the class, these should be easy. Pretty much all the ones with the oxygen are easier because you got that oxygen atom sticking out in some form of, it's going to stand out because it's always listed explicitly. All right. So this will bring us to group 4 in your kit there, which are the aldehydes. Okay. And of course our functional group here is sort of like a ketone, but where we have an R, we have the carbonyl, which is the C double bond O. But instead on the other side, we don't have another R group, we just have a hydrogen. So this would be a carbonyl on the terminus of the molecule, whereas a ketone has the carbonyl somewhere in the middle. Okay. Formal IUPAC names. Always end in, and they pretty much will in essential oil trivia names as well, AL or the word aldehyde. And that is not pronounced all. That is pronounced Al, like your Uncle Al. Okay? If you say all, which someone not that familiar with organic chemistry, that is their tendency, you're going to lead someone to believe you're talking about an alcohol. So you have to be very intentional about pronouncing that al, al. The simplest would be what? There you go. Because R could actually be hydrogen in this case. So the simplest one is actually that, which is what? Formaldehyde. What's the IUPAC name? Methanol. And we all know what formaldehyde is used for, right? For preserving things. Methanol. Or formaldehyde. Well, that is not found, methanol or formaldehyde is not found in essential oils. The most common one is a product called Citral. Now from that name, guess what Citral is found in? It's found in citrus oils, yeah. Particularly to the most degree would be in lemon oil of the citrus oils, but it's still a minor component. The interesting thing about Citral is this trivial name does not refer to one molecule. Initially, probably they thought it was one molecule. But what it actually is a combination of two molecules that always, pretty much always, I don't know of a case where one occurs without the other. And so when you see a reference to citral, you have to know that we're not talking about one molecule. We're always talking about the pair, which specifically are neral and geranial. And they are written like this. This one is neral. And this one is called geranial. Now, those are obviously isomers of one another. What kind of isomers would you classify those as? Cis and trans isomers, or geometric would also apply. Which one is cis? Neral, because let's look at that. And it makes it nice because cis, meaning near, you have your two bigger groups on the same side of this double bond, right? Whereas here, the two bigger groups are on the opposite side. What we're doing is we are drawing a line of symmetry, or not symmetry, but a plane, an imaginary plane through the double bond. And we're asking ourselves, are the two bigger groups on the same side of that line, or are they on opposite sides of that line? So, neral is the same thing as cis citral, and geranial is the same thing as trans citral. But they always occur together, and we just call it citral. These are found in things like lemongrass. These are one of their major components. Lemongrass at, say, up to 75% combined. They're in an oil called Litsea cubeba. Around 80%, let's say. These are very similar oils. In fact, they're used to adulterate one another, depending on which one's cheaper at the time. Litsea, to me, has a better odor. It's cleaner. Lemongrass has a little bit of a dirty note to it. And I believe that we have that one, right? We have the lemongrass. Yeah, we have lemongrass. So I don't have Litsea, but take my word for it. It's a cleaner odor. This is probably more common in terms of what people are familiar with. And it's also in Melissa oil. Say, I don't know, anywhere from 15 to 30%, let's say. And it's in a whole lot of other things that minor components like citrus oil, lemon oil. It's in lemon oil. It's the characteristic lemony note. Okay? When you smell that citral, the first thing that should come into your mind is lemon. Lemon heads, yeah. Okay. I'll live with that. Right? That's the typical lemon flavor. So your descriptor here would be obviously fruity, maybe somewhat citrusy, even though to me lemony and citrusy are not necessarily the same thing. But it's definitely a lemony note. Lemon pledge, yeah. So now, smell that and smell it compared to your lemongrass. And see, you got a lot of other stuff going on there. You got some dirty notes going on there as well. And it's a lot, and you've got some ketones in the top notes of that lemongrass, something called methylheptanones in there. But you can definitely smell that lemony note, but it's not as clean as that pure citral. Like the citral better? Now the lemongrass, the Litsea, if you smelled it, it would be a lot sweeter. Even though they're really close, have a lot of similar chemistry, the Litsea is a cleaner oil. It's one of the few oils that we typically call by its Latin name. If it has a common name, you might hear it called Mai Chang, which is a Chinese name, because this comes from pretty much exclusively from China.
Lesser percentage of ketones or something?
I think it has to do with more, because they both have that same methylheptanone, and they have a lot of the things in common. I think there's more of the dirty sesquiterpenes in this that give it that different flavor. But one can be easily used to adulterate the other, and no one would be the wiser, unless you're someone like me who really digs into the minor components. But used to be, I mean, they switch places all the time. It used to be this was really cheap, and this would be about $8 a kilo. This would be about $20 a kilo, and so people would, obviously mix in some of this to make the price cheaper. But then it kind of flip-flopped, and then they evened out the same, and so, it changes all the time. And if you smell, do we have lemon? I don't think we'd have a lemon, do we? If we had a lemon, you'd be able to pick that citral note out. But in lemon oil, it's only in there at about 2%. Believe it or not. It's the characteristic odor of lemon, and it's only in there at 2%. That's how powerful these aldehydes are.
Aldehydes also be more volatile than the alcohols?
Yes, very good point. The aldehydes would be more volatile. Ketones would be more volatile too, but the aldehydes even more so. They evaporate pretty quickly. And they're typically are what we would call a top note in perfumery. You have a top note, middle note, bottom note. That's traditional perfumery.
Like the top note is a major component of what you smell.
Top note's the thing that hits you right off the bat, first thing. They're usually the more volatile components. The middle notes are the things that are not real heavy, but yet heavier than the top notes. And then your bottom notes are your heavy sesquiterpenol notes that are somewhat woody and resinous.
Would octanone be more of a middle note?
Three-Octanone would definitely be a top note. Definitely be a top note. It's very volatile. It's only 8 carbon. It's gonna hit you right away when it's in there. That's why at 1% you can notice it pretty.
So is the way you tell like top note, middle note, bottom note is like how volatile they are? That primary.
Well, it's not just that alone, because something could be very volatile and also be odorless. I mean, oxygen's pretty volatile, right? So they are linked for sure. Yeah. You could also have something that's relatively non-volatile that could come through pretty pronounced. Odor's funny that way. So next one I want to talk about is a closely related one, which is Citronellal. Okay. Which is basically just Citral minus a double bond. This one should also be very familiar to you when you smell it. Soap, because yeah, it is using a lot of soap fragrances. But it's also the smell of, guess what plant? Citronellal plant. Yeah. It's the main component of the Citronellal plant. And it depends on the origin. You have Citronella java, you have Citronella Ceylon, which have different percentages, but in both of them it's a very significant component. And it's a very powerful component. Very strong. To a major degree, it's found in Citronella and in a product called Eucalyptus citriodora. Which is also known as lemon eucalyptus. These are similar smelling products, but they have some different chemistry. How does that smell to you? Not good? Yeah, I'm not a big fan of it either, to be honest. A lot of people confuse, believe it or not, a lot of people confuse this odor with a lemony odor. They will describe this as lemony, and I don't think it's lemony at all. So, how do you describe this, other than citronella-like? One of the terms we use in perfumery is the term aldehydic. This would be a good example of, and so with one of the next ones we're going to look at would also be aldehyde C10. So citronella obviously is an important one, used in a lot of fragrances, some products for bug repellency, even though it doesn't really work. We've talked about that. Gives me a headache. I don't know about you, but I really don't like it. So let's move on to one that's a little more pleasant. And that is this guy here. Now sometimes you can see an aldehyde written just with that as the terminal, or sometimes they will actually put the hydrogen and show it explicitly. Either way is fine. This one is cinnamic aldehyde. Oh, wait a minute. Let's see. No, it's the same. I just drew. Maybe I drew it wrong on here. Let me see. Uh-oh. Yeah. Maybe you just can't see it. No? It's not that. No, it's not that. All right. So who's wrong? I hope your sheet is right and my notes are wrong. Because it.
No, you're right.
Is it? Darn it. Yep, this is the right structure. So that means we got to correct all of our inserts. Daggone it. I think that's benzaldehyde that's drawn there, which is your favorite, Corey.
No, it's got
Oh, does it? Okay.
close.
We don't have benzaldehyde, do we? That's not one of your examples. Okay, yeah, we didn't put that in there. It's just not that common in essential oils. Okay, so this is the structure for cinnamic aldehyde. Make a note of that, and those of you who have kits, we're going to get you some new inserts. Glad I caught that. I'm glad you guys caught that. So many places to mess up when you're creating these things. All right, so let's smell the cinnamic aldehyde. And that should jog your memory to something that is familiar. Huh? Yeah, it's an irritating component. Yeah, it'll burn. So be careful. Don't get in your eyes. Now that component is found in cinnamon bark. Okay, one of the important oils that has this as a major component. At about 70%, let's say. It's also found in a related product called cassia bark. It's a different tree, different species, much cheaper than true. This is an expensive oil in the hundreds of dollars per kilo. This is relatively cheap, maybe 20 bucks a kilo, something like that. And it could be up to 90% cinnamic aldehyde. It's a less fine of an odor, harsher odor than the cinnamon bark. The cinnamon bark is a beautiful oil. I would have given it to you, but it's a little more expensive and kind of drove the price of the kit up, and I didn't want to do that. But the cassia it's also a nice oil, and you can definitely smell a lot more going on there than just the straight cinnamic aldehyde. But both the cinnamon bark and the cassia are used in flavors a lot, as you might imagine, right? What's some flavor or some products that you might think that would have that? Pardon? Goldschlager? I don't know. I've never had it. It's a cinnamon flavored? Oh yeah, anything like that. The cinnamon, like
Big red bubble gum.
big red hot peppers. Those red hot peppers, candies. Close-up toothpaste. You know that red toothpaste? Being that, I think Jolly Rancher probably has them cinnamon flavored. Any cinnamon gum, candy, toothpaste, mouthwash, anything like that's going to have cinnamic aldehyde. There is no way you can make a cinnamon flavor without it. It is the characteristic taste of cinnamon. Again, this is a very irritating oil, but it's also one of the most antibacterial. These two oils here are probably one of the most, if not the most antibacterial that I know of. Not only antibacterial, but anti-mold. In fact, I did a study with my daughter one year when she was in grade school. Was that you, Zoe, that we did that? We did that science project where we wanted to test the preservative properties of different essential oils on like bread products. So what we did was we took some tortillas, and we just used bread because it was a good medium. It could be used for anything to see what kind of mold resistance these things had. So we tested things like lavender, peppermint, tea tree, oregano, and then we did the cassia. And what we did was we moistened some tortilla shells, sealed them up, put them in the dark, sealed them up in a Ziploc bag, and then watched them over a period of time. And then, you know, after a month later, you saw some of the more mild oils like lavender, so it would be completely covered with mold. And then you got more harsh into like your tea tree, it was a little better, and then your oregano maybe a little better. But after 30 days, with like 3 drops of cassia bark in there, nothing. No mold. So I thought I'd never seen a study done on the mold before with these, and I thought, it'd be a good thing. Probably could have published it somewhere, but never got around to it. But it's an interesting result. So you can imagine, you know, if someone wanted to make a natural preservative, let's say you have a product and you want it to be certified organic, all natural, you don't want any chemicals in there, this might be something that you could incorporate into the product. Well, the small amount may not make a difference, you know.
3 drops in a bag.
Mm-hmm.
See how many drops, see what the difference is.
Yeah, and that's, you know, we just arbitrarily chose. Perhaps we could have got by with 1 drop. I don't know, you know. How much time do you have to do these things? All right, let's hit the last example of an aldehyde that we're going to talk about. And that is Decanal. This one is not really in any kind of a major component in anything, but it is an important one because it's a very strong one, as all these straight chain small aldehydes are. It's found at small percentages in orange and other citrus. Yes, this would also be called aldehyde C10.
What would really describe the odor of the cinnamic aldehyde as?
I think cinnamon would be a good descriptor. It'd be fine. Now you smell this thing, and you should be able to say, yeah, I can see some orange character to that. Yeah, but it's actually very strong. If you dilute this, like a tiny percent, you can smell it. I mean, tiny. In fact, these small aldehydes, like the aldehyde C8, C10, C12, those things were really kind of the start of synthetic perfumery. Back with the advent of what they called the aldehydic type perfume, which began with, what's the famous ladies' perfume that everyone, Chanel No. 5. Everyone heard of Chanel No. 5? It's a very famous perfume, one of the oldest that's still around. I think it was first produced early 19th century, or early 1900s. And it was the first to use these synthetic aldehydes. Very small percentages, but it made all the difference in the world. It changed the kind of the face of perfumery at the time, and it created a whole new category called the aldehydic perfume. And if you get some, you should be able to pick out some of that's in there. So you guys run out and buy some of that. All right. Just wanted to mention that one because it's just a very simple straight chain that's found in essential oils, and it's important in perfumery. All right, now that covers aldehydes and ketones, and one last thing I want to do before we cover the next group next week is cover a little bit of a side note that is carbonyl related, that has to do with carboxylic acids and the formations of in the carrier oils. Okay, I'm going to just say these are not inessential oils, but they're important. Okay. Now, a carboxylic acid, if you remember from organic chemistry, is defined by R, C double bond O within an OH. So we have an alcohol group directly attached to a carbonyl. That defines a carboxylic acid. Again, not significant at all in essential oils. But where they are significant are in what's called carrier oils, fixed oils, fatty oils, whatever you want to call them, because pretty much all, not all, but most of your carrier oils, or what's called fixed oils, are composed of what's called fatty acid triglycerides. Anybody have any experience with this kind of thing, fatty acid triglyceride chemistry? Okay. Yeah. Well, that's what these, like your olive oil, for example, olive oil, grapeseed oil, just any of these pressed peanut oil, any of these kind of vegetable oils are fixed oils. They're non-volatile. The reason they're non-volatile is because they're composed of these relatively big molecules that are basically a glycerol molecule Glycerol is just a trialcohol. If you imagine it with the reaction of some kind of long chain fatty acid, where this is, this could be 18 to 22 carbons long, it could have various double bonds, and it could be the same one or three different ones, let's say. I shouldn't say 18, I should say 8 to 22, but. And I'm not going to specify here, just some kind of long chain. 3 different fatty acids reacting with glycerol, where the OH, of this would come in and here, and the water gets displaced, or the OH gets displaced. And then you're left with your triglyceride. Okay. The R's could be all the same, they could all be different, 2 could be the same, 1 could be different. There's an infinite number of combinations. And depending on what plant you take, what you press it out of, the difference will be in the ratios of what these R groups, these fatty acid side chains are. Okay. Some of them, when they are unsaturated, in other words, if they have double bonds, they're going to be more susceptible to oxidation. If they're completely saturated, they are less susceptible. They're going to be way more, have a much longer shelf life. So, and I talked there, you'll have this in the notes, but most plant oils have these degrees of unsaturation. That's what. So vegetable fat is unsaturated fat, right? Whereas animal fat is saturated fat, which means they're completely hydrogenated, these fatty acid side chains. But when we talk about this fat saturated versus unsaturated, this is what we're talking about, these fatty acid chains and whether they have double bonds or not. And since most plants have unsaturated fat, they tend to have these chains that have the double bonds and they oxidize more easily. But there's one oil that has an appreciable amount of completely saturated side chains, and that's coconut oil. And coconut oil has these C8 and C10 R groups that are completely saturated. There's a light fraction of coconut oil that has this. Now, whole coconut oil is a solid at room temperature. It has saturated and unsaturated, but there is a fraction of the coconut oil that you can separate off that's completely saturated. The fat is more like animal fat. It makes an oil called fractionated coconut oil. This is a very useful oil in massage therapy because it's more like animal fat, it absorbs into the skin cells better. It's not as heavy because it has these smaller fatty acid side chains, so it doesn't leave you that heavy, greasy feeling when you're getting, I don't know how many of you had a massage. Most of you probably, if you've had a massage, you've probably never had an aromatherapy massage, but if you've had an aromatherapy massage, they will take a carrier base and they'll blend in essential oils with it, and that's what they're rubbing into your muscles, okay? The massage therapist who's really up on his or her stuff will use, a lot of times, fractionate coconut oil because she knows that it gets into the skin better, it doesn't leave you greasy, it washes out of her sheets much better because it's a lighter, it doesn't stain her sheets, his or her sheets, and it's just a really good product, and it never goes rancid because there's no double bonds. It's a great product, and I talk about it here because it is a very highly used product in the essential oil / aromatherapy industries. It's also a food group. This is in salad dressing. The one I'm talking about, the fractionated coconuts in salad dressings and a lot of different products. But important, and the only way I could introduce it would be to talk about, what is a carboxylic acid, and then, next group I think we're going to be talking about esters, which is what this is. These are ester groups now. And like I said, we'll get into that next time. And I think that's it for today. Any questions?